Okay, this first one, December 2018. Wait. Okay. All right. So you have a batch fermentation broth. Okay, a batch fermentation broth. Sorry if my line is not that good because the phone that I used to okay. Yes, the phone that I use for my data is actually being used by my other daughter, so I'm using the Unify, so it might slow. Okay, so bear with me. So this is a batch process. You have a 10,500 liter of the fermentation broth, the liquid. Okay, broth is some kind of liquid you use for fermentation. This is anaerobic kind of thing, fermentation, bio kind of thing. The temperature of the broth is at 1 to 1 degree C, and you want to cool it to 37 degrees C before it can be used. Okay, normally 37 degrees C is our body temperature. So since good bacteria which can live in our body is at 37 degrees C, so we want to reduce it to 37 degrees C. Okay, so the batch is cooled by placing it in a large room where the temperature is set at 35 degrees C. So if I can just a simple drawing, so assuming this is the room, so the broth or the fermentation in a tank maybe, or in the beaker, 10,500 liter cannot be in beaker lah. So the broth is here. Okay, initially at T of 1 to 1 degree C. And this room is at T 35 degrees C. Okay, it's some kind of heat exchanger. You know, you have heating medium, cooling medium. So you want to reduce the broth from 1 to 1 to 37, you need a cooling medium. Okay, so that you can reduce the temperature. So your cooling medium will be the room. And then assume the density of the broth is 1.1 kilogram. And the capacity CV is already given here, 4.5. The rate of cooling Q is proportional to this one. This is the rate of cooling Q. Okay. And the T is in degree C, your Q is in kilojoule per minute. All right, so now you are asked to derive a differential equation for the variation of the temperature with time. Provide the initial condition and prove that the temperature at any time can be related to this expression. So you have to integrate the differential equation to get the expression and then sketch. All right. So this one is a batch process. So you should write the closed system lah. Okay, a closed system. MCV dt equal to Q dot minus W. Okay, so you cancel the W, no information on the W is given, and then you replace the Q with this one. But you have to be careful because you have a negative sign there. Okay, a negative sign there that indicate the rate of cooling. Okay, given here the rate of cooling. Rate of cooling, what do you mean by rate of cooling? Means that the broth must release. Okay, must release the Q, must release the heat. So release means negative. Okay, so the rate of cooling is actually the heat released by the broth. All right. So it should be a negative. This is just an expression. This one given is an expression. So you have to consider the positive, negative. Remember, to the system, out of the system, you have to consider that whether positive or negative. Okay, so for this one, it's release, so it's a negative, so you have to put the negative here. Okay, And then now we calculate the M. Remember, M is actually in the broth. It's the broth lah, the broth punya mass. Okay, it's not the room. So the M is calculated using the volume and the density given in the question. Okay, this is just like our example, the one we discussed in our lecture. Your density, you have to find the density. Last time the example is water. So this one is the broth. So the density is given, the volume is given. So you got the flow, or the mass of 11550 kilogram. Okay. So next you put in the value in the question, in the equation. So make sure it must be a consistent in unit. Make sure it must be in degree C per minute, because this one dt over dt must be degree C per minute. So if you look here, your Q is kilojoule per minute here. Okay, your mass is kilogram. Your CV is kilojoule per kilogram degree C. And then if you cancel this kilojoule, this kilogram with this kilogram actually will be on top here. So you're left with degree C per minute. So is that. Okay, the unit is what as the differential equivalence punya unit lah. Alright, so you simplify that, you got this, negative 0.0916 T minus T room. Now you replace the T room with 35 degrees C. If you want to replace it here, then it's fine. Okay, 35 degrees C. So the initial condition T0, your T, remember the change of the temperature that we are looking is the temperature of the broth. It's not the temperature of the room. Okay, temperature of the broth. So that's why you need to consider the mass of the broth, the temperature of the broth. Okay, so this is the change in the temperature of the broth from 1 to 1. We want to reduce it to 37. So we want to know the expression. And then the initial conditionnya adalah 1 to 1. It's not 35. 35 is the room temperature. 35 is the room temperature. So we are not interested with the change done by, we do not want to see the change with respect to time with regards to the room. We are interested to the broth. Okay. So if the question asks you to derive the differential equation of the room, then you have to consider the room lah. All right. So accordingly, you have to see the question lah. All right, so this is the expression for the differential equation. Now we have to integrate to prove that you got the expression as given in the question. So now by integration, so this is at 1 to 1 to T. Okay, this is your dt, negative 0.0916. So you simplify it, you got this one. So if let's say initially you didn't put the negative sign in front of the Q, then this will be positive lah. Okay, so don't just left it positive. There's something wrong somewhere in your concept. So that's why you got you got net positive. But make sure you change it to negative, considering the release, the absorption. Okay, so we are able to prove that the expression of temperature with respect to time is 35 plus 86 exponential negative 0.0916 T. Now the sketching, this is the sketching. So the sketching, you can use any 2 points to sketch. So the first sketching, if of course lah, at T0, the temperature is 1 to 1. Okay, T0, 1 to 1 degree C. So that is the starting point for you to sketch. And the second point, you can take this expression. By taking this expression, you put the T, if you put the T equal to 0, okay, if you put the T equal to 0, it will be 35. Macam mana pula T boleh 0 situ lah. Bukan 0. Infinity. Infinity. If the value is very big, then the exponential will be, let me check, negative 0.0916 times, it's a very, very big value of time, then you exponent it, will be 0. Okay, so it cannot be 0 lah. Assume it to be infinity lah. Assume it to be infinity. T, Allah. T infinity, this T. The negative 0.0, this one. No. Where's my mouse? Okay. So this one, you put T equal to infinity. So you got your temperature will be 35 at the end. Okay, so here. So this one. So it's infinity. T infinity is unknown T. So we just draw a line that the line is almost touching the 35, which is the temperature at infinity time. Okay, so you have the sketch. At least we see the pattern lah. It cannot be a straight line here. It cannot be a going up line. It cannot be this one. This one we call what? Concave up, concave down. I can't remember that, but one of the pattern lah. So it cannot be increasing, cannot be a straight line. Okay, because this expression cannot be a straight line lah for sure kan. If you go there, cannot be a straight line. A straight line, you got what? Y mx plus c. So if you have this kind of thing, then it's a straight line. Okay, that's very general lah itu. Okay, and then this one. Okay, another point. Selain daripada infinity, you can use at steady state. And steady state is actually at infinity lah. So at infinity, your temperature is 35. So sama lah tu. Alright, so number B, prove that the time taken for the broth to cool to 37 degrees C is 41 minutes and the rate of cooling is 158.67. So once you got the correct, actually this question help you a lot actually, because you are already given the expression, you just need to prove. If you are not able to prove, you still able to solve question B because you can use the expression given. So you use the expression given here, you put the 37 there, and then you got 41. So this one you can simplify lah. You kata the 41 minute. You cannot left with 41.06 nanti bukannya 41. So you have to make sure it is 41. It's about 41 minute. Okay, just put in the temperature 37 because you want to know the time for that broth to cool down to 37 degrees C. So it require 41 minutes. And the Q required. So the Q required the rate of cooling. Okay, it's up to you whether you want to put positive or negative. So because the question already mentioned about rate of cooling. Okay, rate of cooling means release. So the value is 158.67, but the sign is negative. So up to you whether you put positive or negative. But to calculate, you just put in here and then put the final temperature, the room temperature, and convert it to kilowatt, and then you got this 158.67. So that's it. Okay. So any question for the first one? Any question? If no, then I move to the second question. So this second question, taken from the textbook, but the old version of the textbook. It's not the new version. The red color, it's not the purple color. So because the purple color is now chapter 10, transient is chapter 10. The old version is chapter 11. Okay, so the old version, there are many questions there actually, but the new version, so many questions being slashed, so dia tinggal sikit saja question. Alright, so this one 11.25, if you refer to the old one, this one. Okay, this one, you got it here, not in the purple one. Okay, so 11.25, you have a steam radiator. So the steam radiator is used to heat 60 meter cube room. Okay. So the radiator actually using saturated steam uh, to operate, and that saturated steam in order to heat the room, that saturated steam condense. Okay, so kalau kita can draw, so you have a radiator here. So in the radiator ni, they are using saturated steam. So that saturated steam coming in and then coming out. So coming out ni dia condense ni. Ni saturated liquid, here is saturated steam. Okay. So the room is 60 meter cube. Okay, so this one is also kind of heat exchanger. Okay, kind of heat exchanger. Okay. I just marking design project material balance actually. So my task to mark design project. There is a group of student heater. The purpose of heater is to heat the stream, right? But you know, I don't know. The temperature increment is only 6 degrees C. Okay, it's only 6 degrees C for a heater. Okay, I wonder. It's okay. Okay, 6 degrees C. Normally for a heater, we thinking of, you know, increase quite high temperature lah kan. Quite high temperature. It's not from negative 10, you know, from negative 20 to negative 14. Okay, using a heater. Okay. All right. They are our friends here doing their design project. Hopefully not from their group lah. Okay. So this one kind of heater and kind of exchanger. You have the saturated steam, and then you use the conversion of the saturated steam to saturated liquid. So because from when you condense, you reduce or you release the heat. Okay, from steam to liquid, you release Q. So this Q will be used to heat the room. All right. So the heat loss from the room to the outside. Okay, room to outside pula ni adalah, this is the heat loss. Okay, from the room to the outside. All right. So where T is the room temperature, T0 is 0 degree C is the outside temperature. Okay, at the moment the radiator is turned on, the temperature in the room is 10 degree C. So 10 degree C. Just before you start the time to T0 je, T0, T je, T0, terus temperature jadi 10 degree C. This is very ideal lah. Okay. So let M dot S kilogram per hour denote the rate at which steam condense in the radiator. Okay, so M dot S is the mass. Okay, the mass of this stream lah ni, M dot S. Saturated steam at 3 bar condense in the radiator and emerge as a liquid at the saturation temperature. Okay, it may, okay, tak apa. So next is the N kilomole is the quantity of air in the room. The air is 60 meter cube. So the quantity, mass, the mass or the mole of the air in the room. Write a differential energy balance on the room air, assuming the N remains constant, means that the quantity of the air in the room tu sama aja. Initial finalnya sama, and the okay, and evaluate all numerical coefficients. Okay, take the CV of 20.8. Now my question is, this system, it is a closed system or open system? Closed or open system? Anybody?
I think it's an open system, Doctor.
You think open system ni dia?
Yeah.
How about the rest? Open. Akasha pun open. How do you know? What is the indicator saying that it's open? No, is it the rate given? The rate, the kilojoule per hour, the what else? The kilogram per hour. Is that your indicator of saying it is open? Or uh, what? Radiator. Radiator is part of the system. This one, the differential energy balance on the room air. You see, you are required to derive a differential energy balance on the room air, this room. Okay, this room. Where the radiator just part of the room. Okay, radiator is part of the room. So, it's a close actually. It's a close. Because you see, no mass in, no mass out with respect to time. Okay, we are not given any indicator saying that, okay, the radiator, okay, this is the mass of the radiator. It's a fixed volume, a fixed mass of the steam condensed. So this is actually the mass of the radiator lah, the saturated steam. So is within the radiator mass to m dot s2 is within the radiator, not which is in the room lah. Okay, so but still in the room. The radiator is still in the room, not out of the room. So when you have no mass in, no mass out, so itu adalah open and close. If you have saying that there is 10 meter cube per minute of air being fed to the room, then there must, if only inlet, then still will be closed. Okay, if you have inlet, outlet, then baru ada jadi open. This one is closed. Okay, nothing to do with the any flow in and out. Okay, so the equation will be this one. This one. Now the M is N because M is mass, but it is actually can be replaced with mole. Okay, because the question already asked us to denote N as the mole of the air in the room. Now we are interested to see the temperature change of the room. So we need to consider the M, if I can write the initial formula for that closed system. Okay, so the M here refer to, because we are referring to the mass, we want to see the change of the mass in the room. The change of the temperature in the room. So the mass must be the mass in the room. The CV must be the CV of the room. So the CV given here, capacity of air. So where the air in the room, okay? So air lah, okay, bukan room lah, okay, sorry, air, okay, air. So the mass of the air, the CV of the air, the dt over dt is the temperature of the air in the room with respect to time, and the Q is also the Q of the air, all right? So M, this M can be replaced with N here, as mentioned there, N. So this one, okay, this is quite very tricky. Okay, and for your information, the question in your textbook, the old version, the question is quite tricky. I myself also need times to understand. Okay, sometimes tak faham pun. Okay, this one, to find the mass or to find the mole of the air, you need to use the standard condition. If you can recall, this one is actually from chapter 5 of your CPP1, your material balance subject. Okay, standard condition. So you see here P1, V1, PS, VS, N1, RT1, NS, RTS. Okay, so this is actually, you need to record that chapter 5. You compare with the standard. You know the volume, 60 meter cube. Now you want to find the mole. Okay, and you know the temperature. Okay, so V1 is the volume. your air volume tu lah in the room tu. Your N1 is the one you're looking for. RT1 is temperature of the room. PS is standard pressure, VS standard volume, and S standard mole. RE is a gas constant, so it will be the same. And the TS is the standard temperature. So if you go here to find N1 is you multiply volume with NS, TS divide by VS over T1. So this is your V1. Okay, this is your NS, standard NS. Your standard volume is this one, 22.4 meter cube. If you go to chapter 5, you are given one more 0.02214 something. So it's equivalent lah, this 1 meter cube. So 1 kilo more is 22.4. 22.14 ke 22.4, you refer to the table lah. So meter cube, so 1 kilo more. Okay, so this is the VS. And this is the TS, the standard temperature, 25 degrees C. Okay. 273, 25 degrees C and 0 degrees C. Okay, sorry, 0 degrees C. And this is your T1, the condition of the air, 10 degrees C and given there. The temperature in the room, when you start the time, 10 degrees C. So 10 degrees C. So you got the mole is 2.58 kilomole. Okay, itu satu. Okay. Getting the N is a bit confusing dah. Macam mana nak boleh dapat N kan compare dengan standard ni. Okay. One more is on the Q. Okay, as mentioned there, Q is rate of heat loss from the room to the outside. Okay. So heat loss from the room to the outside. Now the heat loss is given here. But this loss is still not considering the conversion of your steam to liquid. The saturated steam to liquid is not yet considered. So that's why you see here, because loss, okay, because you release heat. When you convert steam to liquid, you release heat. That heat also is a loss from the room, okay, from the air, okay, means that from the radiator, the loss mix with the loss of the Q tadi tu, and then they become together loss lah of the system, okay. So the second loss of the because of the conversion from steam to liquid is also negative, okay, and then this is heat of vaporization because as mentioned there, the condense at the saturation temperature. Saturated steam condensed to saturated liquid at saturation temperature. So no other effect, is only conversion of phase change. So the phase change, this is the phase change value, heat of vaporization. Why I put negative? Because it's steam to liquid. Okay, steam to liquid is negative lah. Steam to liquid. Kalau liquid to liquid to vapor, dia tak jadilah loss kan. Tak jadi loss. Okay. So it's vapor to liquid. It's a negative value. Okay. So it is also a loss. Okay. And then you put it together. So negative, dia jadi plus lah. So this one is as what we mentioned loss tadi tu. So you add in here and your N now is 2.58 kilomole. Your CV 20.8 given in the question. This one 2163.2, you go to table B6. Remember, if you have temperature pressure, using the steam table, you have temperature pressure, you have to opt for temperature. If you have pressure, then refer to the pressure. So if you, as given here, 3 bar. So 3 bar, you go to table B6, looking to 3 bar, looking at the evaporation, heat of vaporization too, you notice it is this value lah, 2163.2. And the temperature, initial temperature is 0 degrees C, T0 to T0 here is given here, 0 degrees C. Okay. So when you put in, simplify, you got this one. 40.3 m dot S minus 0.559 T. At T0, your T is 10 degrees C. Okay, the room temperature is initially at 10 degrees C. Okay. So next, write the ni and then calculate the steam condensation rate required to maintain a constant room temperature of 24 degrees C. So room temperature ni adalah yang kita derive tadi ya. Remember we are deriving equation for the room, air in the room. Okay. So if you want to maintain the temperature at 24 degrees C, so what will be your M? Okay, what will be your M? Okay, so steady state Okay, steady state sebenarnya. 24 degree C ni constant room temperature can only be achieved at steady state condition lah. Steady state. Okay, so your steady state condition occur at this condition. dt over dt is 0. So when you put 0, you got this expression. Now, if you want to maintain the constant temperature at 24 degree C, or steady state temperature at 24 degrees C. So you replace the T with 24. So you got the rate of the condensation will be 0.333 kilogram per hour. So that is the rate of the condensation from saturated steam to saturated liquid in the radiator in the room. Okay. Now you are asked to integrate the transient balance to calculate the time required to achieve a temperature of 23 degrees C, assuming the steam rate is as we calculated in B, which is 0.033 ni lah. So you put MS as 0.333 here, and you integrate, you got an expression this one, and then you put the T, because they want to know what is the time required if you want to reduce increase the room temperature to 23 degrees C. So you put 23 degrees C here lah ni. So it is actually 4.8 hour. Okay, 4.8 hour. Basically it's logic lah because your flow condensation ni is very low. 0.33. So you release the Q to quite slow lah kan, quite slow, and then you takes time lah to increase the temperature from 10 degrees C nak naik kepada 23 degrees C is 4.8 liter, but the room is 60 meter cube, so mungkin logik lah kan. Okay, so any question?
No, doktor.
No.
Okay.
Okay ya, Azhar dah release dah, DP1 dah submit dah. Search release lah, bahu dah ringan sikit rasa kan.
Tak
Okay,
juga
so
doktor. Banyak kerja lain.
alright, so I think
doktor jadi examiner ke? Exam ni?
seminar what? Presentation
DP.
apa? DP1 I mark MEB.
Oh, boleh lah tengok rubik doktor. Kita orang hantar dah.
Yeah, I know. Tapi tak boleh lah bagi tahu Rubik tak boleh tengok. Saya dah tanda. But ada some of you punya nama tu saya nampak ada lah. Tapi saya tak boleh cakap lah siapa yang saya tanda. It's confidential. Oh, confidential. Okay, so kalau tak ada, itu sahaja untuk hari ini. So next week saya akan release the assignment. So we will have no class, no tutorial, no lecture. But you will need to fill in the attendance lah as a proof of you doing the assignment lah. It will be a group work, so make sure you find a friend of your of 4 to 5 member for each group. So you decide by your own. I will release by letters by Monday lah, hopefully Monday, and to be submitted by Monday juga lah, a week. I will give you a week to solve. Saya plan nak manipulate the design project punya info ni, yang dia orang bagi ni. As examiner, I got the data, so I want to manipulate their data so that I want you to solve in your assignment tu lah. Hopefully it can be done lah. Hopefully it can be done. Alright, so kalau tak ada apa-apa, that's all. Thank you very much.
Thank you, doktor.
Ya, sama-sama Amir. Sama-sama.
Thank you very much doktor.
Ya, sama-sama Ahmad.
Doktor.
Thank you, Doktor.
Thank you, doktor.
Amir.